Welcome to the distance learning program on Android by Inabus. In this chapter, we will be seeing the various data storage methods available in Android. We will be covering shared preferences, using the file system, persisting data to a database using SQLite, and content provider. Shared preferences. Under shared preferences, we will be seeing how to create and retrieve shared preferences, using the preferences framework, and changing the UI based on stored data. Creating and retrieving shared preferences. Shared preferences allows the users to store private primitive data in key value pairs. They are used to save any primitive data, for instance booleans, floats, ints, longs, and strings. Get shared preferences method. This is the method that is used if there is a need of multiple preferences files identified by name, which is specified with the first parameter. Get preferences. If there is only one preferences file, then this method can be directly used without any parameters. To write values in shared preferences, call edit method to get a shared preferences editor. Then add the values with methods such as put boolean or put string. Commit the new values with the commit function. To read the values, use shared preferences methods such as get boolean or get string respectively. Let's now see a demo of creating and retrieving shared preferences. First, I create a new Android project and name the project. Select a target and name the package. Open the default activity which was created by the editor. Now let's create a shared preferences object. And the method we use to do this is get preferences. And we need to specify a mode for this shared preference. And I'm going to set it as mode underscore private, which means that no other application can use this preference file. This preference file can be accessed only by the current application. Create an editor object to edit the preference file. Now using the editor, one can insert as many as key value pairs. Multiple key value pairs can be added to the preference file. Once all the key value pairs are put inside the preference file, it's required to commit the editor. This makes sure that all the changes are saved. Now let's see how to use the shared preference file and retrieve the data from the shared preference. Using the same preference object, you can use the get methods to get the key value pairs. First parameter the key which we use to enter the key value pair. The second parameter is the default value which is written in case there is no key in specified preference file. Now let's create a text view object and set the text of the text view with the string that we obtained from the key value pair. By doing so, we will be able to know whether our shared preferences file was saved correctly and we were able to retrieve it correctly. Now let's run our application to check whether we have correctly created and retrieved the shared preferences. The string demo has been retrieved from the shared preference which we created in the same activity. Now let's have a quick recap of how to create and retrieve values from shared preferences. First, we need to create shared preference object using the getPreference method or the getSharedPreference method. The getSharedPreference method is used when there are multiple preferences files for the same application. While creating the preference file, we need to make sure that we add in a parameter which specifies whether the application can be read or written by multiple applications or can be used only by the current application. Then create an editor object using the edit method and then put in the required key value pairs using the put methods. Then finally commit the editor to make sure that you save the shared preference file. To retrieve shared preferences, create a preference object and then use the get methods to get the corresponding key value pairs. But make sure that you use the same keys which you used to create the key value pairs. If the shared preference doesn't contain the key which you have specified in the get method, then a default value is returned. Using the preferences framework. In case of saving the user settings in shared preferences, Android provides a preferences framework. The preferences activity is the base class for an activity to show a hierarchy of preferences to the user. The user preferences created using the preference framework will be automatically persisted. This is in turn taken care by shared preferences. In this demo, we'll see how to use the preferences framework. First, I'll create a new Android project and name the project. And select a build target and then name the package. We will open the default activity which was created by the editor and remove the setContentView method which is used to set the UI of the activity. Now going to the resources folder, we will create a new Android XML file and select the resource type as preference and name the file as settings.xml and select the root as preference screen and then press finish. Now we will edit the preference screen to include our settings values. We will add two edit text preferences tags. The required parameters for these tags would be title, key, and a summary. We will copy paste the edit text preference to add another value. And I'll change the title as password and the key as password, the summary to enter password. And also we'll mention that this text field is a password text field. And we'll save the file. Now going back to our activity, we need to make our activity extend preferences activity. And we will add the add preferences from resources method by passing the ID of the XML file we just created. Now let's run our application to check whether we have imported the preference framework correctly and set the values. The two edit text preferences we set in the XML file are reflected here. On clicking username, I can set in the value for the username object. On pressing OK, the value is persisted in the shared preference file. Similarly, I can save the password field too. Now going back to the username field, we can see that the value which I entered earlier has been persisted. Now I will show you a demo of changing the UI based on stored data. First, we will create a new Android project and name the project. Press next. Select a build target. Press next and name the package. And press finish. Now we'll open the project and select the default activity which was created by the editor. Now we will edit the layout file of the activity. We will add a checkbox widget to the screen and edit its properties. We'll change the text to show first screen and set the checked property to true. Now we will create a new activity in the package and name it as second activity. Make sure that the class extends activity class and press finish. Add the onCreate method. Now let's create a layout file for this activity. Create new Android XML file. Select the root layout as linear layout and the name of the file as second screen.xml and press finish. Now add a button to the layout file and edit the button properties. The text of the button is changed to reset values and save the XML file. Now going to the first activity, now we will create a checkbox object and map it to the checkbox that we have created in the XML file. And we'll create a new shared preferences object using the get preferences method and pass the mode as private. Now we will try to get a boolean value from the shared preference object, but since we are creating the preference object for the first time, we are sure to get false for the boolean value. But we'll set the default value as true. We will assign the boolean value to a variable. Now we'll create a if statement to check the boolean value and perform our next operation. In the else statement, we'll create a new intent targeting the second screen activity. Now we will write a set on check change listener for the checkbox object. Now inside the onCheckChange function, we'll get the state of the checkbox and assign it to the showScreen preference variable. We need to create an editor to edit the preference value. We will use the editor object to put the boolean value inside the preference. Then we need to call the commit function to save the editing. The main purpose of the checkbox in this activity is that if the shared preference value is set as true, this screen is shown to the user. If not, the next screen is immediately called after the display of this screen. This happens so fast that the user doesn't get a chance to view the first screen when the user launches this application. Now, in the second activity, we'll set the content of the activity from the layout file which we created. We'll create a new button object and map it with the button we created in the XML file. We will write an on-click listener for the button object. And inside the onClick function, we will reset the boolean value to true so that the next time when the user launches the application, the first screen is shown. We'll create a shared preferences object the same way similar to that we created in the previous activity. We'll use the get preferences method and set the mode as private. We'll create a new editor object and we will use the editor object to put the boolean value of the variable. We will set it as true and we will commit the changes. And we will finish the activity. The same way in the previous activity, we will finish the activity once it calls the next activity. Then click on the Android manifest XML file, go to application and add the new activity which we have created. Save the manifest file and we will run the application to check whether our shared preference is saved and the UI is changed based on that. Now in the emulator we can see the checkbox is selected and it shows show first screen. I click on the checkbox and I close the application by pressing the back button. Now I will relaunch the application and it takes the user directly to the second screen. Now I will reset the values. The application is finished. And now when I relaunch the application, the first screen is shown. Thus, the UI can be changed based on the stored data in shared preferences. Using the file system. Under this heading, we will see the following topics: creating and accessing files, files as raw resources, XML file resources, and external storage via an SD card. Creating and accessing files. Files can be directly saved on the device internal storage. By default, files saved to the internal storage are private to the application and other applications cannot access them. When the user uninstalls the application, the files are removed along with the application. To create and write a private file to the internal storage, the following steps are to be performed. Call openFileOutput method with the name of the file and the operating mode. This returns a file output stream. Write to the file with the write method. Close the stream with close method. To read a file from internal storage, the steps to be performed are: call openFileInput method and pass it the name of the file to be read. This returns a file input stream. Read the bytes from the file with the read method. Then close the stream with the close method. Now we will see a demo of creating and accessing files. We'll create a new Android project and name the project press next, select the build target, press next and name the package. and press finish. Now we'll open the project and select the default activity which was created by the editor. Let us use this activity to create a file. Let's edit the layout file of this activity. We'll delete the text view which is present and add a multiple line edit text box. We'll edit the properties of the edit box. And set the number of lines to be 5. Below the edit box, we will add a button and edit its properties. We'll change the text as write file and save the XML. Now going back to our activity, we will write the necessary code for file writing. We'll create private members for the edit text and the button. We'll map the edit text with the edit text we created in the XML file. We'll map the edit text with the edit text box we created in the XML file. Similarly, we will map the button to the button we created in the XML file. We will write a set on click listener function for the button. And inside the on click function, we will write the code for writing the file. First, we need to create a file output stream object. Now, inside a try catch block, we will assign the file output stream. We will assign the file output stream with a value. We will call the open file output method by passing the file name as the first parameter. and the mode as the second parameter. Now, using the write method, we will write the contents of the edit text box to the file. We will create a finally block and close the file output stream. And we will save the activity. Now, we will create another activity to read the same file. We'll make sure that the class extends the activity class. We'll add an onCreate method and use a XML file similar to the XML file for the file writing activity. We will change the text of the button to read file. Now, in the read activity, we will copy and paste the edit text and the button variables in the new activity. We can copy the mapping statements also. Now we will write a new on-click listener for the button. And inside the onClick function, we will write the code to read the same file which we wrote in the previous activity. We'll create a new file input stream object. We'll create a new try catch block. We will assign the file input stream object by calling the open file input method, and we'll pass the file name. We will use a byte reader to read the contents of the file. Then we will assign the contents from the file to the text box in the activity. And finally, we will close the input stream. In the first activity, after writing the file, we will call the next activity. Now we will run our application to check whether we are able to create and access the file successfully. The application is launched and we will enter a text string inside the text box. And press the write file button. The file is written and the next activity is called. Now I press on the read file button and the text string from the file is fetched and is populated in the text box. Files as raw resources. A static file in the application at compile time can be saved in the project's resources raw directory. It can be opened with open raw resource method by passing the resource ID. This method returns an input stream that can be used to read the file. One cannot write to the original file. Only read operations can be done on the file. Now we will reuse the same demo which we used for creating and accessing files. We'll edit the project so that we can read files from raw folders. First, we'll create a new raw folder in the resource folder. And in the raw folder, we will create a new text file. and we will save the file. Now we will edit the Android manifest file such a way that the read activity becomes the launcher activity. Now going back to the read activity, we will delete the code in the on-click listener of the button. Now we will write the necessary code required for reading the file from the raw folder. To access the resources in the resources folder, we need to create the resources object using the getResources method. Create an input stream object create a try-catch block and assign the input stream with the value attained by calling the openRawResource method on the resource object. The parameter for the openRawResource method is the integer value of the file. This can be obtained by raw dot the name of the file. Now using a byte reader, we can read the contents of the file and assign it to a text box. The text box is filled with the string obtained from the file. Create a finally block and close the input string. Now we'll try running the application and check whether we are able to successfully read contents from the file in the raw folder. The activity is launched and I press read file button. The text from the file in the raw folder has been fetched and is populated in the text box. XML file resources. The files in the resource XML folder are treated a bit differently than other Android resources. A stream is not used to access these files because they are compiled into an efficient binary form when deployed. They can be of any custom XML structure. Again, we will use the same demo project to access XML file resources. I'll create a new folder in the resource folder called as XML and press finish. And now in the XML folder, I create a new XML file. I manually create a customized XML file. This is an XML file with a list of persons inside a people tag. Every person has got a first name as a property. Now I save the file. The XML folder, and I give a file name as people.xml and I save it in the folder. Now going back to a read activity, I delete the code in the onClick listener. Now we will write the necessary code to read the values from the XML file in the resource folder. Create a resources object to access resources from the resource folder. Create a XML pull parser object and assign a value by calling the getXML method on the resources object. The parameter is an integer which is accessed by using the R class. r.xml. Name of the file. Now create a new string buffer to save the contents of the file. Create a try-catch block and pass the XML using the parser object. Once the values are stored in the string buffer, the text box can be filled with the string buffer values. The text box can be populated with the string value of the string buffer. Now let's run our application to check whether we are able to fetch all the elements from the XML file in the resource folder. The read activity is launched and I press on the read file button, which fetches the first name of all the person in the XML file and populate in the text box. External storage via an SD card. Every Android compatible device supports a shared external storage that can be used to save files. This can be a removable storage media such as an SD card or an internal non-removable storage. Files saved to the external storage are world readable and can be modified by the computer when they enable USB mass storage to transfer files on a computer. Before any work is done with the external storage, always call get external storage state to check whether the media is available. If API level 8 or greater is used, then use get external files there method to open a file that represents the external storage directory where you should save your files. If you're using API level 7 or lower, then use get external storage directory method to open a file representing the root of the external storage. Again, we will use the same file operations demo project to create and access files in the external storage. First, let's edit the Android manifest file such a way that the files operation demo activity becomes the launcher activity. And let's add permission to the Android manifest file. Click on permissions, press add and select users permission and select write external storage. Save the manifest file and open the file operations demo activity. Delete the code in the on-click listener. Now I delete the code in the on-click listener. Now let's write the code necessary for creating a file in the external storage. Let's create a file name. Let's create a file name. We'll create a new file. Now we have access to the SD card. Let's check whether the SD card exists. And whether it's writable. Now, now let's create a folder in the SD card. Now let's check whether the new directory is existing and is whether writable. Let's create a new file. Create a try block. Create a try catch block. And create the file. Now check whether the file is created and is writable. Create a file output string. create a try catch block, and write to the file output stream. Fetch the string from the text box and write to the file. Create a finally block and close the file output stream. And save the activity. Now go to the read activity. Now going to the read activity and deleting the code in the on-click listener. Now going to the read activity, I am deleting the code in the on-click listener. You'll write the necessary code to read the string from the file stored in the external storage. We'll create a new file and pass the path of the existing file as the parameter. Check whether the file exists and is readable. We'll create a new file input stream. We'll create a new try catch block. And we'll use a byte reader to read the contents of the file. we will assign the string which we obtained from the file to the text box. Create a finally block and close the file input stream. Let's now run the application and check whether we are able to write to the external storage and read from the external storage as well. The file operations demo activity is shown. And I press the write file button. The next activity is called. Now I press the read file button. Persisting data to a database. Under this heading, we will be covering the following topics: creating a separate database package, using a separate database package, and creating a personal diary. Creating a separate database package. Android provides full support for SQLite databases. It allows to store structured data in a private database. Any databases created will be accessible by name to any class in the application, but not outside the application. The recommended method to create a new SQLite database is to create a subclass of SQLite OpenHelper and override the onCreate method. An instance of the SQLite OpenHelper implementation can be obtained by using a constructor. To write to the database, call getWriteableDatabase. This returns a SQLite database object that represents the database and provides methods for SQLite operations. This SQLite database can be populated using the insert command with appropriate column names and values. Using a separate database package. An instance of the SQLite Open Helper implementation must be obtained using the constructor of the helper class. To read from the database, call getReadableDatabase. SQLite queries can be executed using the SQLite database query methods, which accept various query parameters such as the table to query, the projection, selection, columns, grouping, and others. For complex queries such as those that require column aliases, SQLite Query Builder should be used as it provides several convenient methods for building queries. Every SQLite query will return a cursor that points to all the rows found by the query. The cursor is always the mechanism with which one can navigate results from a database query and read rows and columns. Now we will see a demo of creating a personal diary using SQLite database. First, we'll create a new Android project and name the project. Select the build target, name the package, and press finish. We'll open the project. We will put the database class and its helper classes in a separate package. So we will create a subpackage. First, we will create the constants class where we will store all the constants. We will create constant variables for the following data. First, we will have the database name. We will set it as my diary. Next, we will have the database version. Then we will have the table name. Then we will have the column names. We will add another column name. we will add a date column. Finally, we will have another column called as key ID, which will act as the primary key. Having set all the constants, now we will create the helper class. We will name it as mydbhelper. We will have to make sure that this class extends the SQLite open helper. We will create a new constructor. We will create a static variable. Which will save the syntax for creating the table. We will mention the key ID column. As the primary key. And we will mention it as auto increment as well. Then we will add the other column names. And mention the data type as text and not null. We'll have to take care of the commas in the syntax. And finally, we will add the date column. And mention the data type as long, as we'll be saving the date in terms of milliseconds. Now we will override the onCreate method to create the SQLite database. We will write a try catch block. Inside the try block, we will call the execute SQL function on the DB. We will pass the create table string as the query. The onUpgrade method is usually used to upgrade the database. Right now we will leave it as empty. Now we will create the MyDB class. We will create fields for SQLite database and context. We will also create a field of type MyDB helper class. We will write a constructor function which accepts context as the parameter. Inside the constructor, we will assign the context field with the context obtained as the parameter, and we will instantiate the MyDB helper class. The constructor of the MyDB helper class accepts context as the first parameter, the database name as the second parameter, and the factory value can be set to null, and the database version as the last parameter. Now we will write a close function we will call the close method on the DB. We will also write a open function we will create a try catch block and try to open the DB inside the try block. This is just to make sure that if the open method is called before the database is created, then an exception will be thrown. We will use the get writable database method. If it fails, then we may use the get readable database method. Now we will create another function by name insert diary, which returns a long value. The function may take two values as parameters, which are both strings. We'll create a try catch block. Inside the try block, we'll create a new content values object. We'll put the various values into the content values. We will also put a date value inside the content values. Then finally we will call the insert method on the DB. The first parameter is the table name. Second parameter can be set to null, and the content values is put as the third parameter. This function returns the inserted row of the record. So we will return this as the return value of this function. If the insertion fails, then we will return a negative value. Now we will write a function to get the diary entries. The return type would be cursor. We will call the query method on the DB, which takes the table name as the first parameter. And the rest of the parameters can be set to null, as we are not filtering any diary entries based on any filter criteria. So we will be returning all the records in the DB. Now we will go to the personal diary activity and write the necessary code to capture the diary entry from the user. We will edit the layout of this activity. We will remove the text view which was already present inside the layout. We will add a text view inside the layout and edit its property to be title. Then we will add a edit text box. Then we will add another text view and set its text as content. We will add a multi-line edit text box. We will set the number of lines to be 4. Then we will add a button below the edit text field. We'll set the text as add diary entry. Now we will return back to the activity. We will create fields for the edit text box and the button. We will instantiate these fields and map it to the edit text box which we created in the XML file. We will instantiate the button object as well and map it to the submit button in the XML file. We will write a set on click listener function for the button. And inside the on click function, we will write the necessary code to add the diary entry to the SQLite DB. We will also create another field of type mydb. We will instantiate the mydb field. We'll also call the open method on the DB object. Now inside the on click function of the button, we will call the function save to DB. We will create the method, and inside this method we will write the necessary code to insert the diary entry into the SQLite DB. We will call the insert diary method which we created and get the values from the two edit text fields and pass it as parameters. Then we'll call the close method on the DB object. We will also reset the text in the two edit text fields. And save the file. Now we'll create another activity to show the list of diary entries that we have added. We'll name the activity as display diaries activity, and we'll make sure that it extends the list activity of the Android package. We will create the onCreate method. We will create a new layout for this activity. We'll set the name as display list.xml. And select the linear layout as the root element. We will add a list view to the layout. We will edit the layout height to be match parent. And we will change the ID to Android colon list. This is to help the list activity find the list view. We need to create another layout file for the individual rows in the list item. We will name it as row.xml and select relative layout as the root layout. We will add a text view to the top corner of the layout and add another text view just below the first text view. We will edit the properties of the text views. We will change the text of the first text view to be title and the second text view to be recorded date. We will also change the ID values so that it will be convenient for us to remember them later. We will save the XML file and go to the display diaries activity. We will set the content of this activity using the content view method and pass the layout which we just created now. We will create a MyDB field. We also need to create a MyDiary model class. We will have the title, content and date as the fields of this class. We will also create a constructor with these values. We will set the fields with the parameters from the constructor. We will create a field of type MyDiary. We also need to create our own adapter class extending the array adapter. And we'll set the type as MyDiary. We'll create a constructor for the MyDiary adapter class which takes context, layout resource ID and the array list as the parameters. We'll create 3 fields in the diary adapter class, one for the context, another one for the layout ID, and the last one for the array list of type my diary. We'll name it as items. Inside the constructor, we will map these fields with the parameters from the constructor. Then we will override the getView method. We will create a new view object and assign it with the value from the second parameter. We will check whether the view is null. If it's null, then we will inflate it with a layout inflator. We will instantiate the layout inflator. And we will use the layout inflator to inflate the view. We'll pass the layout ID as the first parameter and the root as null. We will create a new myDiary object and instantiate it from the items array list using the get method and passing the position as index. Then if the myDiary object is not equal to null, then we will assign the title and the recorded date to the text views in the row layout. We will create a text view object we will instantiate it from the text view which we created in the row layout. Similarly, we will create another text view object and map it with the text view we created in the row layout. Then we will check whether the text views are not null, and then we will set the text of these text views. With the title and recorded date respectively. Before that, we will also create getters and setters for the various fields in the myDiary object. Now inside the we will check whether the text view objects are null. If not null, then we will assign the text to the text views. We will use the getter which we created now for the myDiary class. Similarly, we will check the recorded date text view. If it's not null, then we will set its text. We will use the get recorded date getter function, and we will save the file. Now we have created the diary adapter. Now we have created the diary adapter class. So inside the display diaries activity, we will create a field for the diary adapter. Inside the onCreate method, we will instantiate the DB object. We will also call the open method on the DB object. We will create another field of type array list in the display diaries activity class. And we will create a method called getData, which we will use to get the diary entries from the SQLite database. We will call the db.getDiaries method and assign it to a cursor. Then we will pass the cursor and store the records in the array list. We will use a do while block to iterate through the cursor and get the diary entries, and we'll get the string from the cursor. We will create a long variable called rec date and get the value from the column. We will create a date format object. We will instantiate the date format. We'll create a new string called str date. and we will use the date format object to format the milliseconds into a date string. We will create another string called str content and fetch the content value similar to the other two values. We'll create a new myDiary object with the values which we have. We'll add the diary object to the diary objects list. Now back in the onCreate method, we will instantiate the diaries object list. Then we'll call the getData method, which will get all the data from the SQLite DB and store it in the diaries entries list. We will instantiate the diary adapter. We'll pass the context as the first parameter. The layout ID of the row and the diary entries as the third parameter. Then we'll call the setListAdapter method and pass the diary adapter as the parameter for the method. Now we'll go to the my personal diary activity, and inside the diary activity, after the save to DB method, we will call the next activity. So we'll create a new intent. We'll call the display diaries activity. We will use the start activity method and pass the intent as the parameter. We'll save the activity, but before running the application, we will add the activity in the Android manifest file. We'll save the manifest file and run our application. The application is launched and the my personal diary activity is shown. I enter the title as first entry and set the content as with random string. And I press the add diary entry button. It takes us to the next activity where the list is shown. Currently only one item is there in the list, which is the first entry. Now I go back to the my personal diary activity and enter another diary entry, and I set the text as second entry and the content with random text, and I press add diary entry button. The list is shown and another entry is added to the list. Thus, SQLite database can be used to save and retrieve data. Content provider. Under this heading, we will see the following topics: using an existing content provider and creating a content provider. Using an existing content provider. Android ships with a number of content providers for common data types like images, audio, video, and personal contact information. All content providers implement a common interface for querying the provider and returning results, as well as for adding, altering, and deleting data. It's an interface that clients use indirectly, most generally through content resolver objects. A content resolver object is obtained by calling getContentResolver within the implementation of an activity or other application component. When a query is initiated, the Android system identifies the content provider that's the target of the query and makes sure that it is up and running. So, generally these content providers enable sharing of data between applications. Now, we will see a demo of using an existing content provider. This is my emulator and this is the contacts application in the device. I've added 6 contacts to the contacts application. Now we will try to use the contacts content provider and fetch these contacts in our application. First, we'll create a new Android project and name the project as content provider demo. Select the build target and name the package. Press finish. Open the default activity which was created. Change the activity tag to list activity so that our activity extends the list activity. We'll edit the layout file of this activity. We will remove the text view which was already present inside the layout and add a list view to the layout. We will set the layout height property as fill parent and we'll change the ID as Android list. We'll save the XML file and return to the content provider demo activity. Inside the onCreate method of the demo activity, we'll create a string array called projection. This array should contain the column names to be fetched from the content provider. So we will use the contacts.id column and the contacts.displayname column. We will just try to show the display name of all the contacts in the contacts content provider. Then we'll create another array called display. This will contain the column names to be shown to the user. We will be showing only the display name and not the ID. So it's only necessary that we add the display name to the array. Then we'll create another integer array and name it as display views and instantiate the array. We need to mention the ID of the text view which we are going to use to show to the user. In this case, we will use the default Android list view. So it would be android.r.id.text1. Then now we'll create our cursor. We'll use the manage query method. It requires the URI of the content provider. The projection. And let the selection and selection arguments and sort order be null, as we are not filtering any contacts. We will create a simple cursor adapter object. We will fill in the required parameters. The first one is the context. The second one is the layout of the row. So it would be android.r.layout.simple list item 1. If required, we can create our own custom layout and then mention the layout ID here. Then the second parameter is the cursor, and the third parameter is the display fields, and the last parameter is the display views. Now we will call the set list adapter method and pass the contacts adapter. We will save the activity file, but before running our application, we'll go to the Android manifest file and go to permissions tab and add user permission to read contact data. We'll save the XML file and then run our application. The application is launched and we can see the contacts which we saw in the contacts list displayed here. Thus, data from an existing content provider can be used across various applications. Creating a content provider. The steps involved in creating a content provider are as follows. Set up a system for storing the data. Most content providers store their data using Android's file storage methods or SQLite databases. Android provides the SQLite Open Helper class to help you create a database and SQLite database to manage it. Extend the content provider class to provide access to the data. Declare the content provider in the Android manifest.xml file for your application. Implement the following 6 abstract methods to expose the data: query, insert, update, delete, getType, and onCreate. Call contentResolver.notifyChange to notify listeners when there are modifications to the data. Let's now see a demo of creating a custom content provider. For this demo, we will reuse the same project which we used for SQLite database. We'll open the project. We'll go to the data package. We will create a new class. We'll name the class as diary content provider, and we'll make sure that the class extends the content provider class in the Android package. Now, inside the diary content provider class, we'll be able to see the 6 abstract methods. We need to override these 6 abstract methods to perform any operations on the content provider. First, we'll create a MyDB field. We'll create a private static URI matcher. We will also create a static int constant. We will create a static string. Let the name of the variable be authority and the value be the package name. We'll also load the URI matcher. We will call the add URI method and pass the authority as the parameter, and the path would be the table name, and the code would be diaries. Now we will override the onCreate method. We will instantiate the MyDB object. We will open the DB object. We will override the query method as well. We will create a cursor object. We will add a switch case block. And pass the URI match function to the switch. And for the case statements, we will use diaries. Then we'll populate the cursor with get diaries method. Then outside the switch case block, we will add a notification command. It takes the content resolver as the first parameter and the URI as the second parameter. And return the cursor. Similarly, if the content provider is to be used for deleting or inserting, then the corresponding methods needs to be overridden. Go to Android manifest file. Add the content provider which we created now. And add authorities property to the provider tag. Set the package name. And save the Android XML file. Now install the application in the device. The application is installed. Now the data in the content provider is available for other applications. So we will try to create a new Android application and access the data from the My Personal Diary content provider. So we'll create a new Android project and name the project as content demo. We'll set the build target and name the package. Press finish. Open the default activity which was created and edit the layout file of the activity. We'll remove the text view which was already present inside the activity and add a larger text view. We will edit the text as diary entries and save the XML file. Now we'll go back to the content demo activity. We'll create a field for the text field. We will instantiate the text view and assign it to the text view which we created in the XML file. We'll create a string called my URI. We will set the path of the content provider. We'll create a URI object. By passing the string which we created just now. We will get a content resolver instance. Then we will create a cursor and create a query with the help of the content resolver. We will pass the content URI which we created now as the first parameter. And rest of the parameters as null, since we are not going to filter any data. We'll call the start managing cursor method. So that we bind this cursor to this activity. We'll create a new string builder instance. we will pass the cursor and get the items in the My Personal Diary content provider. Inside the do block, we will try to get the string value from the content provider. Then we will append the string to the string builder object. Then we will append the text to the text view. We will save the file and run our application. The activity is launched and we can see that the first entry and the second entry from the My Personal Diary SQLite database has been fetched through the My Personal Diary content provider. So it's always better to use content providers to share data between applications.